Awesome. So this is how the Lac Operon works. Over here we have the Lac I gene. Right here we have the promoter. Here we have the operator. And here we have Lac Z, Y, and A. The Lac I gene, what it does is it is a gene sequence that makes this protein when it is transcribed. This protein is called the repressor. The repressor binds to the operator and represses transcription of lactose enzymes or lactose digesting enzymes. When the Lac I gene is mutated, it can't make the repressor, so it drops it. It can't make the repressor, so there is no repression, and RNA polymerase here at the promoter makes it, but slowly. It makes lactose enzymes. So that's how we know what the Lac I gene does. The operator can also be mutated. When the operator is mutated, it becomes a site where the promoter can't bind. And RNA polymerase continues, but slowly. Awesome. Then, when the promoter is also mutated, it can't bind, and that's the exact same thing. This is the promoter. The promoter is very important for detecting if glucose is present. Because right before the promoter is something called the CRP site, which is where this water bottle right here is the CRP, where the CRP comes and binds to. So this is CRP, it binds. But the hard part is if there's nothing called CAMP, which is detecting if glucose is present, it doesn't know to speed up regulation of the lactose digesting enzymes or not. So when there's high amounts of glucose in the cell, then there's no CAMP. When there's low glucose, there's a whole lot of CAMP, and CAMP comes and binds to CRP, which then binds to the CRP site, which then increases RNA polymerase transcription. Awesome. When there is no CAMP, which means that there's high glucose in the cell, then it's slow. And the biggest thing to remember with this is the repressor is more powerful than it all. So if the repressor binds to the operator, it doesn't matter if there's glucose, which means if there is glucose, then there's no CAMP, which means it can't transcribe. If there is no glucose, which means there is CAMP with the CRP binding, then it still can't transcribe. But if the repressor falls off because allolactose comes and binds to the repressor, then it transcribes super fast, depending on if there's glucose present. Awesome.
Yes?